Okay, so we're here on our 2-column proofs day. Just a quick reminder, all the extra credit on Khan Academy is due by tonight. You have an online assignment from last class that is also due by tonight, and today you'll have another online assignment. So if you'd flip on over to page 7, which is today's notes day. So today we're on 2-column proofs. And before we start into these, I want to show you just some reasoning for why we do our 2-column proofs. So I found this paper on Google. It is written, it looks like by a college professor, but he gave 3 reasons for why we do proofs. Proofs are all around us. It is quite possible to get better at them. It is a challenging area for a lot of students, but you can get better at them. And it really will help in real life because of the reasoning skills you develop. And so what a proof is, proofs do not stop with these 2-column tables that we're doing in 10th grade geometry, where you are right now. They go on to be just like the reasoning. So the proof is in your head, the argument, justification, or reason something's true, and it has to be logical to be a proof. So remember I told you as we started the conditional statements, this unit's all about the logic, developing those thinking skills. And so just a few examples of where you use proofs are down here. It says, when you reason with yourself to buy something cheaper in large cans rather than smaller. When you play a game like Minesweeper and figure out, oh, there has to be a mine here. When you're playing card games, you figure things out, okay, why does this work? It's the logic skills that do show up in life. So if you want to read more of this article, it's kind of interesting, but I'm not going to read a 3-page paper to you. So stick with it. If proofs are something difficult to you, sometimes it's easy. A lot of students just don't like these. It's okay, stick with it. It'll get easier, and it develops those thinking skills. So just like we learned last time, we have a few keywords here of reflexive, something is itself. Symmetric is just when we switch around. And transitive is our transfer. So remember, transitive, we're always taking half of this and half of this, and because the other half of both of those is CDD, we can transfer them into one statement where they join together. So those are 3 things you're going to learn here a lot. So just whether you see them under segments, whether you see them under angles. This symbol, if you haven't seen it before, is our congruent symbol. So we're saying segment AB is congruent to segment AB because it is itself. Or angle A is congruent to angle A. And so that's what you see when we're talking about geometry terms. When we take those away and get just the letters and just the equal sign, that's talking about the actual length of the segment, and it's something a little bit different. So here we're going to go through and we look at the information they give us. We're given that line K and L bisect each other, and then we're given that BM is congruent to CM, and we're asked to prove that AB equals AM plus DM. Lots of different letters there. And so let's take this one step at a time. So the given's already listed out for us, but if not, we would just list it out. CM equals DM. So I'm talking about this little section equals this little section, and I have to give a reason why. Well, my reason why is right here in bisect. So you have these papers we'll be using in class and in tests, and so as I'm looking for my reason why, I'm going to go through, if I can't remember the reasons, and find, okay, what matches, and I find, oh look, definition of bisects. It says if bisects is in my word, I'm going to use that definition somewhere, and so that's my reason. Okay, so by definition, if it bisects, my 2 halves are equal. Now, BM equals DM. And so I have to look, is that my definition of bisects? No. BM's on this line, DM's on that line. But I do have BM is here, it equals CM, and DM is here, it equals CM, and so that's where I use that transitive property. Okay, this one is on your list of, and that we haven't gone over this in definitions yet, but definition of congruent is just when I take away those geometry symbols and just say, well, if these two segments are congruent, they are the same length. So that's called definition of congruent. It tells me my next reason has to be segment addition postulate. And so since I know I'm trying to get to AB equals these, I would say if AB has to equal AM plus BM, okay, that's my part plus part equals whole. And then last of all, it asks me to prove that DM is there. So I'm going to take my BM and DM and substitute it in. And so as I'm doing these, I'm just going step by step and trying to find the reasons for why these statements are true. The statements are given to me, I just have to see why they're true. Alright, so go on to the next page. And so here it tells us angle AEB is the complement of BEC. And so complement, we know, means things add to 90. And we have the angles here. We're asked to prove that AED also equals 90. So we have our given definition of complementary angles. We know they add up to 90, so I'm just going to write that out as angle AEB plus angle BEC equals 90. Okay, when I see the word complement in there, I'm going to have to show that they add up together. And then this says the measure, and technically this is the measure of each of those angles. So the measure of AEC equals the measure of AEB plus BEC, and that's just our angle addition postulate. And so I've now listed out that a measure of AEB plus measure of BEC equals 90, measure of AEC has to equal the two parts equals the whole. Therefore, I can prove that these two now equal each other. And so that is my transitive. The next one they gave to us, but it's just, this is a straight line. We can see it's a straight line and it has the arrows going out, and so they're equal 180 degrees. And so therefore, the measure of AED plus 90 has to equal 180 because I'm plugging the 90 in for AEC. That substitution, and then to get measure of AED by itself, I just subtract. So I'm just working step by step through and finding what's the most logical thing to put in each of these lengths here. Alright, now we're just going to do a quick vocab review. So if angle RST is congruent to TSU, and that's a keyword there, TSU is congruent to VWX, then RST is congruent to VWX. So of your options here, of the ones that are basic ones we went over, which of our vocab words, which property is that showing? And hopefully you figured out that it was transitive. Anytime we have the and in there and we're transferring half of this and half of that into one statement, that's our transitive. Alright, and the next one is a really easy symmetric. We just switched the order. Okay, so now we are asked to write our own two-column proof. So they didn't give me the statements anymore. I have to write it. And so let's go step by step. I'm always going to start with my given. So M is the midpoint of RT. And my reason is given. And I'm always going to number the statements and reasons just to make sure it's clear. I'm asked to get to MT equals RS and SM. And so I'm trying to say, okay, what would my next logical thing to do? Well, I have the word midpoint, so I'm going to define it. And so, by definition, if M is the midpoint of RT, then RM is congruent to MT. Okay, so that's an easy one. Anytime I have the word midpoint, my next step is going to be to define it. Okay, now my answer wants to have RS and SM in it, and so that lets me know, okay, that's just a part plus part equals whole. So next I can write the length of RM has to equal RS plus SM, and that is my segment addition postulate. Now I see that I'm almost to that statement. I just need to substitute MT in for RM. And so to make sure I have everything straight, I'm going to go ahead and say instead of segment RM is congruent to segment MT, that means the length of RM equals the length of MT. And that was our definition of congruent. And now I can just go ahead and substitute MT into the place of RM. So MT equals RS plus SM, which is what they asked me to prove. My reason, because I'm replacing an entire side, is transitive. Alright, so when you have that, flip to the next page. And here are two proofs here. And so what I'm going to do is I'm going to write out, this is called proofs practice. And so we're going to take a few minutes to go work with your group and see if you can figure these out, and I'll show you the answers. But you're going to have on each one a statements and reasons. So it doesn't give you the nice little chart here, so we're just going to make our own. Here you'll have statements. And then reasons. So go ahead and pause the video, work with your groups, see if you can at least come up with your givens, see how many steps you can figure out, and then come back. Okay, so hopefully you paused that and got at least a few of these statements written down. And so if not, go ahead and pause the video again and see if you can come up with a few of your own reasons. Alright, and these are the statements for that part. So, hopefully you followed directions, pause the video, tried to process this on your own. But let's go through the reasons now. And so first of all, sometimes it helps to come back to my drawing and label parts. So if BF bisects AF and AFC and CFD, that means I can mark this part and this part as congruent, and if it bisects that. And then if CFD is congruent to BASC, I know that CFD has to be the same as my DFE. And so first, if I mark on here, I'm like, okay, does my given say these two angles are equal and these two angles are equal? I'm asked to prove that this angle, AFB, also equals CFD. So I'm asked to prove that those two are equal. And so my first reason is really easy. Those were my two givens. Okay, AFB equals BFC. That was our definition of bisects. And then CFD and BFC, that was another given. And sometimes we could have written both givens first. Usually if there's a bisect, we're going to go ahead and define it before we give our second given. Alright, now, because my final answer has CFD on the second part, I just need to flip it over. I need to switch the order. And so that's why I did this. I switched it over and my reason is symmetric. And then the last reason, I went ahead and took BFC and replaced it with my AFB because they equal each other. And so that is my transitive. Alright, so then our next one has a lot of moving parts. So again, if we label, so AG bisects CD. So if AG right here bisects my CE, which is my whole thing, CD, that means CE has to equal ED. So every time I see the word bisects, I'm going to say, okay, which part's equal? So that's my definition of bisects. And I did all three here to save space. So if IJ bisects CE, well, that means these two parts have to be equal also. And if BH bisects ED, that means these two parts have to be equal. Okay, and then by definition, 2 halves equals a whole. That's something we've talked about again. And so my next step was to take, okay, well, CE also equals 2 of KE, and ED equals 2 of FD, and so that's also definition of bisects. Okay, because bisects means we have equal halves, it also means 2 halves equals the whole. And then I can go ahead and transfer these in and take 2 of KE has to then by definition equal 2 of FD. And since I'm trying to get to this KE equals FD, I go ahead and divide both sides by 2. It's my division property of equality. And then 6, I just wants it into the congruent segments format, and so that's my definition of congruence. Okay, so that is the end of our notes. You now have an online assignment. Make sure if as you're checking your answer that you're also studying. If you got something wrong the first time, make a note of it to study so that you know how to get it correct the next time.